Circular motion, exercise question 29, from H.C. Verma. Here is the top-down view of the circular road. The car moves along a circular path of radius r equal to 50 meters. Inside the car, a plate is fixed perpendicular to the radius. A small block of mass 100 grams rests against this plate. As the car turns, the block needs centripetal force directed toward the center, and this force is provided by the normal contact force from the plate. Now for part B, the plate is slowly turned. As the plate rotates by angle alpha, the centripetal force splits into two components on the plate, one along the normal to the plate, and one along the plate surface. When the tangential component exceeds friction, the block starts sliding. The question says, a car moving at 36 km/h is taking a turn on a circular road of radius 50 meters. A small wooden plate is kept on the seat, perpendicular to the radius. A block of mass 100 grams rests against the plate. The friction coefficient μ between the block and plate is 0.58. Part A, find the normal contact force exerted by the plate on the block. Part B, the plate is slowly turned so that the angle between the normal to the plate and the radius slowly increases. Find the angle at which the block will just start sliding on the plate. Let us understand the key concepts. For the block to move in a circle, it needs a centripetal force equal to mv squared over r. When the plate is perpendicular to the radius, the entire normal force from the plate provides this centripetal force. Now, when the plate is tilted by an angle alpha, the centripetal force has two components on the plate. The component normal to the plate is mv squared over r times cos alpha. This becomes the new normal force n prime. The component along the plate surface is mv squared over r times sin alpha. This must be balanced by friction. The block starts sliding when this tangential component equals μ times the normal force. Let us solve part A first. Convert the speed, 36 km/h equals 10 meters per second. The mass is 0.1 kilogram and the radius is 50 meters. Since the plate is perpendicular to the radius, the normal force N equals the centripetal force, mv squared over r. Substituting the values, N equals 0.1 times 10 squared, divided by 50. Computing this gives us N equals 0.2 newtons. Now for part B. When the plate is tilted by angle alpha, the centripetal force resolves into two components on the plate. The normal component is mv squared over r times cos alpha. The tangential component along the plate surface is mv squared over r times sin alpha. The block just starts sliding when the tangential component equals μ times the normal force. Writing this condition, mv squared over r sin alpha equals μ times mv squared over r cos alpha. The common term mv squared over r cancels from both sides. So we get tan alpha equals μ, which is 0.58. Therefore, alpha equals tan inverse of 0.58, which gives approximately 30 degrees. The answers. Part A. The normal contact force exerted by the plate on the block is 0.2 newtons. Part B. The block starts sliding when the plate is turned by alpha equals 30 degrees. Exam tips. First, when resolving forces on a tilted surface, always decompose them into components normal and tangential to the surface, not into horizontal and vertical. Second, the critical angle at which sliding just begins is always alpha equals tan inverse of μ. Remember this, it comes up in many friction-related problems. Third, always convert units. 36 km/h equals 10 meters per second. A quick trick, just divide by 3.6. Like and subscribe for more circular motion solutions at MAGPIEHUB.